Welcome back to a follow-up video. This will be regarding the mesh accuracy for 3D generative AI reconstructions, and this is a case study. We see it over here on Arctic 3D. This is the bronze statue. This will be the mesh, as you can see it. And the input for this was the following. So this one with texture. Now let's take a look at the model outputs. We see over here this will be a horseman, and we see the following weapon within his right hand. Now this will be the model created using CSM, and they added a new model that now offers better details, and we see that this will be the output. I will have this exported as a GLB file, and I will have that loaded over here near the 3D scan. So if I will go to File, Import GLB within Downloads, we are gonna see that model. So this is one. If I will hit Import, we're gonna see the model will be like this. I will just rotate it 180 degrees over here, and I will slightly scale this and move it to match the original model. So we see it over here. We're gonna see the details on the horse. Over here it's a little bit off, as you can see it over here. It had multiple elements like that, and over here the model will have the following output. Now we see that the weapon is not attached to the character over here, but this was also a tricky image, since from this perspective it's quite hard for the generative AI to understand that that will actually be within the hand of the horseman. Now let's jump to the other tools. The following one will be high 3D gen. We see this from ByteDance, and the same image was the input. This will be the mesh. In this case, we're gonna see that the weapon has been completely trimmed. Even though over here within the normal bridge, we're gonna see some elements, but those will not be linked. And this actually did the following. As you can see, it added that to the horse, so something like a unicorn. So I'm gonna export this mesh as well. And within Blender, I will import that. The file format again will be GLB. I can also make this as a list, and this will be the mesh. We see the file size, so 15.5 megabytes. And we're gonna see that this will be quite dense. We see that the size is roughly the same as the one created by CSM. But we're gonna have the following details over here. So we see over here on the character leg, there will be more details than the one over here. But overall, the proportions for the horse head over here are a little bit off, even though we have more details on the horseman over here. But again, that weapon will be completely not recreated. As we can see, we have this added over here to the horse, so something like a unicorn. And we're gonna see the total number of edges, in this case 1 million. The one with CSM, it will have only 360,000, and this is the original scan, so 375 edges. But we see within the original scan how many details we still have over here preserved. If I'm gonna smooth this out, you're gonna see both for the horseman, for the rider, and even from the ground over here, there will be many details for those rocks. Now, regarding the alignment, we're gonna see that this will be as the 3D scan. We see this left leg over here, but this one, it's a little bit trickier, as this is a lot narrower. If I will take a look over here from the right view, we're gonna see over here the proportions for the horse. The one created by CSM will be a lot more wider and heavier, as you can see over here. Also, the position of the horse head, this is slightly rotated over here. This will be more let's see, vertical position over here. And this is quite narrow. Now let's jump to the following one. This will be Tripo. And I will open the model. Again, the same image, the same screenshot was used as an input. And this will be the output model. I will have this extracted as a GLB file, so I'm going to have this downloaded. The weapon, just like within CSM, will be generated. It doesn't have the end over here, but this one didn't as well. You see over here that the tip of the weapon. So let's go over here and have this GLB file loaded as well. This will be the file, so 16 megabytes. We're gonna see that the size will be roughly the same as for the others. I will have this rotated, scaled, and also now moved over here. Now let's analyze the model. If I will go over here to the front view, we're gonna see the orientation of the horse head. So it will be like this. But overall the proportions of the horse are quite good. If I'm gonna overlap this, over here we're gonna see it like that. So the horse created by CSM will be a lot heavier over here, as you can see. And this will be quite close to that reference. And also the details for the horseman and for the horse are quite interesting and well defined. Now let's go to the next tool will be Hyper 3D Rodin, and this will be the mesh. As you can see, this will be the most narrower out of all of those. I'm gonna export this as a GLB file. We see that this is currently being generated. And we can import this. This will be the smallest one. Now I'm using a free account over here, so with some paid versions we can also go for high polygon over here, but we see that that will require a subscription. So let's import that model over here, file import GLB. This will be the base mesh, and as we can see, this will be the size, so a lot larger than the others, but we can easily scale that down. And we see how thin this model will be compared to the others. And just by looking at this, we're going to see that this will be also the one with less details. The model will only have 53,000 edges over here, as you can see, but we see how skinny the horse model will be over here. And also the weapon will not be recreated over here. Now let's jump to the last tool, which will be Vizcom, and this is that one. And we're gonna have the same problem over here with the horseman weapon. We're gonna have something added to the horse over here in front, and to the back it tried to recreate something with symmetry, as we can see over here. So let's export this, export as a GLB file, and within Blender I will have that loaded. Now this will be the file size, so 11.4 megabytes. This will be the original size, so I'm going to scale it down, rotate it around the z-axis 90 degrees, and move it over here into position, and also scale it a little bit. Now if I'm going to zoom onto this, we're going to see the alignment, and in this case the horse legs will be quite weirdly defined over here, as we can see over here. It will have an additional section over here, and this upper leg and bottom leg will be on the same side. So maybe this is the model with less fidelity compared to that original model. We see over here this symmetry, so this was the only tool that tried to embed that symmetry. So overall we see that the model created using Tripo and CSM will be the only 2 that will actually recreate that weapon in this case. As you can see, this model also is quite interesting, but again, the proportion of the Horseman, this is for high 3D, will not be that good. As we see, the horse will be quite thin compared to the reference over here. I still think the one made with Tripo, in this case, managed to recreate the overall proportions over here. We see over here for those elements on the bottom, and also it has those 4 legs over here, and we see how well it defined the legs of the Horseman, even on this side. The one over here from CSM, this side that wasn't visible, we're gonna see it's not that well defined. This leg, it is pretty decent, but the one over here from Tripo will have both legs quite well defined, especially this one, which was not visible in this case. We see it over here, the last model with Vizcom, we also have those legs, but the proportions over here are a little bit weird. Okay, so let me know in the comment section, what do you think is the best model for this, and which has the best output. Also, if you have any other suggestions for other tools, consider to let me know, and I will also try those. Okay, I will position a similar video over here on the left side, and I will also add a subscribe button to the right. So that's it. Thanks for watching.